I'm gonna talk. I thought I was going to go back really deep in history until everyone started talking about 1981 and 1972 and 2000. But I'm going to go back to 2000. In 2000, Jim Hansen came out with a paper on the global warming, a scenario for how we might be able to constrain global warming in the 21st century. And he started talking. He didn't call them short-lived climate pollutants, but he talked about a set of non-CO2s that included methane, ozone, and black carbon, and that if we pressed on those emissions and also cut CO2, we might be able to constrain climate and try to keep us from hitting dangerous anthropogenic interference in the climate. He put out a paper in PNAS that year, in 2000, which really got a lot of play. Coincidentally, in that year, Tammy Bond completed her dissertation on light absorption by primary particles from fossil fuel combustion, implications for radiative forcing, which put her on the map as really the person who had spent more time studying climate impacts of black carbon than anybody else. I'm going to fast forward to 2013 when a group of 31 authors spent 4 years working on a paper called Bounding BC. It was, wasn't called Bounding BC. It was nicknamed Bounding BC. Sarath Gutikunda is in the audience. He's one of the co-authors of that paper. This actually came out of a meeting that Ray Minhares had organized in 2010, where Tammy stood up and said, just give me 6 months. We can just figure out the climate impacts of black carbon. We don't want any influence. We don't want of anybody on us, and we're just going to figure this out. We'll get back to you. We're going to have international people work on this, and we're going to do it so that we can just sort of put to rest some of the issues, because we know this is a complex science, and it's driving people crazy, and we want to get to the bottom of this. But it took 4 years. And it came out 2 years ago, and the big headline was, soot roll underestimated. It's really way bigger than anybody ever thought. And that's really what almost everyone heard. But really, behind the headline, the big message from Bounding Black Carbon report was, it was a very comprehensive report. And the message is, when you change emissions of black carbon, you change all its effects in the Earth system. And so this big, I'm sorry. This big graphic here really became, is something that you started to see. It's like lots of stuff going on, all the different ways that black carbon is impacting the Earth system, all the different sources of black carbon. And what the study looked at was what did we understand about all of this, and tried to take a look at it. So the first thing it saw was that most of the models just look at the direct effect of black carbon. And so it doesn't even look at all the ways that black carbon is affecting Earth systems. Some of the models look at the cloud effect, and not even all of the cloud effects, which is what you've already heard about from people today. And then a bunch aren't looking at any at all. This is actually the same information put in a graphic form. So what you see here is what most models look at, the direct effect right here. What happens when coming straight from the sun. These are all of the ways that the clouds are influenced by, by black carbon, of which models only simulate some of them, and models don't do much of a very good job looking at what the snow and ice effects are. And then right here are the total effects of just black carbon. And that's what the headline was. Okay, and because we're looking just at black carbon right now, nothing else, the conclusion was there are larger amounts of black carbon in the atmosphere than previous studies had indicated. And so their observations were more than the models. So that was one reason that the estimate was higher. And there was more forcing from each gram of all of that black carbon. Back to comprehensiveness. When you change a single source of black carbon, you also change all the pollutants that are emitted. So up till now, I've only talked about if you just look at black carbon. But as everyone in this room knows, both because you all know it, and because every speaker has talked about it before, and because the booklet that we got sent yesterday and we've gotten today says it as well, there's no such thing as a single source of black carbon. You know, it just doesn't exist. So any source of black carbon also emits a whole set of other pollutants. So, this car, for example, also emits nitrogen oxides, carbon dioxides, organic carbon, black carbon. And if we weren't looking at a car, if we were looking at, say, maybe a brick kiln, it might also be burning coal and be emitting sulfur dioxide. And we use the term co-emitted species to describe that. Two of the most common, the most common co-emitted species is organic carbon. So when you look at how these affect climate, you've got the co-emitted species of organic carbon, which is reflective. And you can think of that as like being as reflective, 1 gram is as reflective as, say, 3 white umbrellas compared to a gram of black carbon, which is as absorbing as 10 black umbrellas. And the smoke of organic carbon is this smoke right here. It's that white smoke. And it's often the black smoke. So sometimes when you see something that's really black, that's organic carbon. It's not the black carbon, even though it looks really black and yucky. And the black carbon is often coming from this orange flame right here. So we've got here the headline, black carbon, twice as absorbing as previously thought. And we've got here the reality that you keep hearing about. Not all sources, when you mix all sources together, you've got this wide uncertainty of what the climate response is going to be, because some sources also have a lot of co-emitted species. And when you have those on balance and you put all the sources together, you actually are going to have a little bit of cooling, which doesn't mean that every source is going to be cooling. It just means when you add every single source, biomass burning, open burning, everything together. So what you're saying is that if you're trying to maximize and grab the carbon black carbon headline, it's not about taming a single black animal. It's more like a flock of rabbits that you have to catch. And it's really not about all rabbits. It's more like a barnyard of animals. You know. Each source, each rabbit has a different character. And there's different amounts of organic carbon and sulfur. It matters what the location of the emissions are. Some emissions are a lot easier to mitigate, and there's a lot of other factors that affect the character of the emissions. So you go from this spectrum. Oh, sorry. Oh, I really have no idea what I did there. How did I do that? Sorry. That was bad. Go from this spectrum where you've got coal-powered plants where we're almost sure they're cooling, although we're not completely sure about that, to diesel engines where where we have really very decent measurements that let us know that the black carbon contribution compared to all the co-emitted species suggests that we really are warming, so that mitigation strategies would definitely have a cooling impact. And that all the way down on this spectrum here. And what this tells us is that the most climate-friendly reductions are the ones with a lot of black carbon in them compared to other pollutants. Even if they're close to being climate neutral, they're more friendly than some of these other solutions. Okay, so this gets back to where we were, that we know that bounding was high for two reasons, that there was a larger amount of black carbon and there was more forcing per gram. But that was 2 years ago, and the science is still evolving. We now know that actually their observations, it turns out there probably is less black carbon in the atmosphere than bounding BC estimated. But this doesn't change the importance of each source or each rabbit. So where are we today? We know that black carbon on its own has a very high positive forcing, but it's made up of a contribution from many sources. For many reasons, but mostly due to co-emitted pollutants, some sources emit black carbons that warms the atmosphere, and others emit black carbon, have sources that cool it. But even for sources that are cooling black carbon, and here's the common theme of this so far of this meeting, improving human health needs particulate reductions. If we want to have the co-benefits, the most climate-friendly reductions will address sources with black carbon. That's it. Thank you very much.